there by your top view. So you see that gap of 30 millimeter clearly there by your top view. So that is why we thought your favorite is going to be what? Solid there. Because assuming this plate is on its own, it's not being assembled with all these other parts on its own. So this is a plate that is at the mid lid. It has a gap of what? Of 30. So we're going to, and it's a gap of 30 with 2 holes of diameter 10. You understand? So if we were to trace the cutting plane on this plate, so it's actually something like this, isn't it? If you can take it, you have these 2 holes here and a gap here. So if we trace if we trace this cutting plane on this plate, so from here till here it will cut, from here till here it's a hole, from here till here it will cut, from here till here it's that gap that I'm talking about. You understand? So that is why we'll have to have this one solid, from here till here solid, from here till here solid, from here till here solid. So from here it will be solid again, even up there, that gap of 30 millimeter solid. Just like this. So now let me section before I put the nut. Let me section before we put the nut. So if we are tracing a cutting plane BP, a cutting plane BP is going to be exposed where? In our front view. So when we section, we use a 45-degree set square. We use a 45-degree set square. So this is it. I'll decide to start with plates. If this was grade 12 or N3, I would have at the end and labeled to say this is item 1, this is item 2, this is item, but this is not assembled drawing. But when we section, we'll section as if it's assembled drawing, because it has already assembled for us. So from here till there I can have, so I'll decide to use this gap. There you go. So there you go. So like this we go. So let me see. Like this. Then I've tried to section this. Remember, the more you position your, isn't it? They must be at an angle of 45. The more they are too tight to each other, it's time consuming. So I've decided to section this plate at an angle of 45 in a clockwise direction. So I'm going to follow it by the second plate at the very same angle but opposite direction. 45 now, and there you go. There you go. There you go. So here it's a gap, which is what we've been through. There you go, which is this one. This one, isn't it? There you go. There you go. Yes. So we've sectioned our plate. So now we can follow it by what? By sectioning these wheels. So let's section them. I'll decide to start with this one. So my hatches, they must be opposite too. Remember, I started with this the way in a clockwise direction. So the second plate anti-clockwise. So now I'm following with this one. But now the space it's supposed to differ. You understand? So I'll decide to use this one. There you go. There you go. we go. There we go. In this side. There we go. The side is not coming. There we go. This we can go. So this was clockwise direction, so this one it should be anti-clockwise direction. There you go. There you go. There you go. So like this. So guys, sorry guys from TikTok, some of your comment I might not be able to read them because I'm actually concentrating on the paper than on the on the screen. So now let's see where can we go. So okay. So from here till there, let's put the 15mm. So the 15mm, there is for 15. So supposed to end up right there. I said to you, don't mind about these holes, ne? There we go. Okay, so now we've answered the question of BP. They by situated in our top view. Let's answer the question, the cutting plane of AA, a full sectional front view of our top view, following by tracing the cutting plane. So the hacksaw started to cut, actually started from here till there, didn't cut it anything, which means this portion from here till there supposed to, we do not have to have hatches here, you understand. So from here till there, the hacksaw cut it is what is going to be in section, which is this one. Just section it. So there we go. There we go. So there we go. There we go. Like this we go. Right, so this one, it was actually talking about diameter 20, so it's going to be short. So that is why I had to draw it faint, you understand? So that is why I had to draw it faint. You can draw it faint, or you can disappear it, just draw it, you just erase it. So now the side, there we go, there we go. Go. There we go. There we go. So the hatches, they will be different because these are different items. These are different items. It's not one and the same thing. You understand? So now let's see what else is going to be cutted. What else is going to be cutted is what is this bolt. So the bolt has to be in section because it's cutted across its height. If it was cutted along its length, you understand, that's when it was like there by our top view, I mean our front view. this bolt, why is it not in sectioning? Because it's cutted along its height, you understand? But there is a, we'll show that it was cutted by some very small hatches on it. I'll show you to the end. There we go. So by tracing cutting plane AA situated in our front view, this is the solution. This is only what is going to be cutted. So now let's see this gap. Are we going to see it? This gap, are we still going to see it? Was this, it will be under. So what is going to be seen is just a line from there till there of what, of a breadth or a width of 20. So which means I can come at this point and record 20 millimeter. So I'll say 10 this side, 10 this side. So 0, 10 here, and 10 right there. So it's supposed to, for now, I'll draw it faint. It's gonna end till we come and analyze it nicely. So if this one goes like this, so this line, this point, this from there till there is going to be clear. Now it is going to be clear because it was hidden from here till there. From here till there we were able to see it. It's proof what indeed this one, it's a gap, you understand? Because from here till there we could see it clearly. So now if we cut, remember whatever that is beyond your cutting plane, we consider it as an offcut. So which means it will come, it will be clear. So now I can take my drawing compass and place it back there and have this one. Remember at the beginning I was scared to draw it dark. So now we are sure what is going to be dark, so you can go back and just darken that one. There you go. So that from here till right there we are having a dark line and dark line. Right, so is there anything left? There you go. This one won't be there, this one already there. So from here to there it will disappear, from here to there it will disappear. Why? Because it will go with an offcut. So the other remaining one, it will be under this wheel. You understand? Under this wheel, because this point is good as if this one. This one it will go, this one it will go out with an offcut. Right. So now let us put the nut which they said is knitted. So it's supposed to be drawn. So to draw the nut, I'll just extend the center of my even this one, extend it. We have to draw the auxiliary or the top view of this nut of ours. First of diameter 10. So I decided to draw them here. Let me not go too much far. Right, I'm tired already. So now to draw the nut, you remember the standard formulas of bolt and nut. So we are going to start with 1.5 times M number. So the M number, which is M10, isn't it? Can you say 1.5 times M10? How much are you getting? How much are you getting? M10, 1.5 times M10, how much are you getting? Because we have to draw the nut here. After drawing the nut, then we are done. So I'm going to say 1.5 1.5 times m number, which is 10. I am getting 15 millimeter. I am getting 15 millimeter. So divide by 2, which is 7.5. So if we divide by 2, 7.5, I can open. Where is my 30 millimeter? Something very close. 5, 6, 7.5. Because we have to start by drawing the auxiliary first. So there you go. Draw it faint. There you go. This is diameter 15, eh? So even this side. There you go. Draw it faint. There you go. Right? Then from there, I am going to place my drawing compass here. Further extend to the center. I can strike an arc here. Strike an arc here. Strike an arc here. So they must be accurate. You can see mine are not accurate. So now I'll take this one vertically down, this one vertically down, this one vertically down, this one vertically down, this one vertically down. There you go. There you go. There you go. So I'm taking this point vertically down, vertically down. So from here going up, we know we have to get our nut, and and the height of the nut, if you remember very well, the height of the nut, so the height of the nut, you are going to see 0.7, not 0.7, 0.7 is the height of the bolt. 0.7 is the height of the board. So we're going to say 0.8 times m number, which is 10. Which is 10. How much are you getting? 8 millimeter. So that's going to be the height of your nut. This is 9. This is 8. There is my 8 millimeter. And so then I can draw horizontal faint line. So I have a point here and a point there, point here and the point here, point here and the point there, point here and the point right there. So that's where you're supposed to get your what to call your nut, top part of it. Let me just position very well. So now I'll join this corner with this one because we're doing this manual. So there you go. Faint. Once it touch the vertical center line, I can stop. And this one with this one. There you go. Faint. So that is why even in the final exam, this part you have to end with it. That is why you put all your sectioning, but the nut end with it because it takes time. So you might be taking time drawing something that is out of order, and then again take this one with this one, faint. So there you go up until it crosses the center. So let me get the exact point there. So this one with this one. So I've got a clear video where I'm teaching how to draw a bolt and nut here in our YouTube channel. You can just scroll down in our videos, you'll see. So now I can place my drawing compass here, further extend till here. I know what I have to draw, get an arc that's going to behave like this. Place it here till right here. So it's something very small. There you go. I can stop here. You understand? So even this side, remember this is a nut. So a nut is supposed to be both sides. So from here till there, from here to right there. So I can do the same thing even this other side, there till there, from here till there, there you go. So from here till right there. Faint. So from here till right there, but further extend up until it crosses the center. You understand? So now I'm going to place my drawing compass here, further till here. Oh, still remember it's what we did on the other side. So I'll start to draw from here till there. So even though it's not clear, but this one that it is the one that it should be clear enough, which is what is most needed. Oh, just point my work. So I have to place it here till right there. There you go. You have to be careful. Stop right there. So to get the smaller, you have to place it right there. There you go. In this side, place it here. There you go. Place it here. There you go. So drawing something very small, I know it's a challenge. So there you go. In this side, there you go. It's coming, you see. So even this side, reduce it just a little bit. There you go. In this side, so now I can have it dark here. Actually this is supposed to be angle 60, but this is too small now. There you go. There you go. There you go. There you go. And there you go. So even though it might not, it wasn't clear enough, so you have to get something of this nature. You have to get something of this nature. So this is your top view, then with your full sectional front view on your cutting plane PP. So this is the full sectional cutting plane. Cutting plane AA. So this cutting planes, they're actually situated here and then here and then. So this is B. So we draw what is being pointed by an arrow. We draw what is being pointed by the arrow. You understand? So what is being what is going to be below or at beyond your cutting plane, you consider it as an offcut. So the PP was actually pointing this direction. So it tells you what you have to draw the full sectional front view. So if it was a half sectional with the left hand in sectioning, so this BP was gonna turn at the center and go down. You understand? So if A again, if is being situated like this is actually talking about a full sectional front top view. You understand why? Because of it's pointing there by your top view. You understand? Again, if it was a half sectional, this was going to turn at the center. It was going to be like this. There you go from here. You understand? So which means it's actually talking about the top view, a half sectional top view with the left hand in sectioning. You understand? So thank you very much guys for watching. That was Mr. Ghosty. See you on the next video. Please don't forget to subscribe and comment. Your comments, they're very encouraging, so comment guys, subscribe, like the video you are watching at that time, and if you've got a question, let us know down there on the comment. Even if you criticize, you remember criticism are also allowed. You understand? It's fine. So thank you very much for watching. See you on the next video. That was engineering drawing of this previous question paper. Previous question paper that was written on the 12th August 2021. So if you look, so which means now I can come and tick here. We've done this one. I'm not quite sure about question 2 and I'm not sure about question 6. In the next video we'll be doing that. So thank you very much guys for watching. See you on the next video. Okay.